Welcome to BeyondBIM. These are certainly unprecedented times for all of us, and we would like to echo the message of many experts to continue to stay safe and, most importantly, at home. So today we hope to give you just a little bit of a distraction in these difficult times and to help pass the time at home. Today's episode is a continuation of interviewing some of the very known academics and co-authors of the newly published book titled Construction 4.0. In this episode, we will discuss virtual progress monitoring in construction management and the future of these practices in a fully connected Construction 4.0 context. Joining us today is co-author Mani Golparvar Fard in the chapter that he titled as Visual and Virtual Progress Monitoring in Construction 4.0. Mani Golparvar Fard is an associate professor of civil engineering, computer science, and technology entrepreneurship at the University of Illinois. He has a PhD in civil engineering, and he's also well recognized and an established academic in the digital construction and civil engineering sector. And this has also been recognized with prominent awards such as the ASCE Walter Huber Award for Innovation in Civil Engineering. And in conjunction to his academic career, he is also one of the co-founders and COO of Reconstruct, which specializes in data analytics for construction projects. And now let's take a look at what Mani has to say on visual and virtual progress monitoring in Construction 4.0. If you could just start off by telling us a little bit more about yourself and your background and what initially got you interested in the construction sector and the engineering field in the first place.
Sure. My name is Mani Golparvar. I'm an associate professor at the University of Illinois at Urbana-Champaign. I am in the Department of Civil and Environmental Engineering in Construction Engineering and Management, and I'm also affiliated with the Department of Computer Science and our Technology Entrepreneurship Program. My background is a hybrid of construction engineering and management, or broadly civil engineering and computer science. In my earlier days, prior to higher education, I was really fascinated by software development, specifically for construction. I grew up in a construction family, and we all had the desire of learning CAD solution in early days. This goes back to the time that Autodesk came with AutoCAD 7, 8. So I had a desire to learn that so I can automate and address some of the issues that we had with creating shop drawings for our family construction business. With that interest, I got into higher education. I did an undergraduate degree in civil engineering. While I was going through that exercise, I was always at the interface of software development and sometimes algorithmic development for the purpose of automating steps in civil engineering. Then I made my way into design in civil engineering, made my way into construction. So I did another second master's in construction, project and construction management from University of British Columbia. And then I moved to University of Illinois, where I decided to formally pursue a degree in computer science. This is a time I was really fascinated by getting into the depth of artificial intelligence algorithms in its earlier days, and specifically explore computer vision, which is the study of images and videos. I had that background of BIM, starting with CAD all the way to my practice and education I had in Canada. And I really wanted to bring the two together to address some of the issues that I specifically was facing on job sites with problems such as tracking progress, productivity, and safety. So I evolved into who I am today, who sits at the interface of AI and construction.
Okay, interesting. So in the new book titled Construction 4.0, you have extensively discussed virtual progress monitoring. Can you just explain what you mean by that concept?
Absolutely. So I want to step back and share some statistics with the people who are listening to the podcast today. The value put in place in construction over the past decade has significantly grown. The numbers that we're seeing in 2020 are significantly larger than the numbers that we had before the recession in 2008. As an example, in the United States, the value put in place has exceeded $1.3 trillion. But as we all know, we have a lot of productivity issues in terms of how we are coordinating and managing labor costs. And labor cost happens to be a significant portion of overall project costs that we have. So if you do the math based on the numbers that publications such as McKinsey or Forbes are putting out, you will see that the potential for adding value in construction is large, and it's really close to about $250 billion a year just in the United States. But what does it really mean for those of us who are engaged in construction? That means because of these inefficiencies that we have in executing projects against the plan, many of our projects end up being behind the schedule and are over budget. In fact, Dodge Data and Analytics did a recent study that shows more than 50% of our projects are behind the schedule. By projects, I'm specifically referring to commercial building projects. And more than 60% of them are over budget. Now, if you ask owners doing construction what metric matters to them the most, they will tell you schedule. Now you may say, why? I mean, why not budget? Why not quality? Why not safety? Of course, all those metrics matter. But the one that impacts the bottom line in making sure that that product that is being built is going to generate revenue for them is really schedule. Every day would matter to them. Budget can be controlled through contract. Quality can be controlled through specification. But the schedule is always the piece that is surfacing as a problematic area. Now, if you really deeply look into the problems that are contributing to that, one is, obviously planning. Over the past 2 decades, we've significantly improved how we do planning. So our companies are really great at creating master schedules. But when it comes to really understanding how much work can be done in 2-3 weeks by subcontractors, trade contractors, there's a lot of room for improvement. The other problem has to do with communication, specifically the area that I focus on, which is, we often send our field engineers or superintendents on the job site with an 11 by 17 sheet, or let's say an iPad with a 2D drawing. And we ask them to walk around the job site and record how much progress is being conducted or executed by various trades that we have on the job site. Some companies purely rely on the subs to provide them with daily reports. They compile them and they generate weekly reports on progress with them. Because the process is subjective, it's very time consuming. Often the type of data that we get out of them are not very reliable. So we wait for an entire week for the team to get into a coordination meeting, often in the trailer, to review how much progress is being reported. And we ask them to start color coding their drawings to tell us, how much progress was made, how does that contrast against the plan, what are the issues that they faced. So from the time that the problem happens to the time that that problem really gets communicated to the project management, we effectively lose at least 1 week. And that's the essence of some of the issues that we're facing in progress monitoring. And if you think about it, the lack of that data, the progress data, also impacts the people who are engaged in the planning. The people who we brought into the project to help us with creating a schedule, often disconnected from this feedback that happens in these meetings. So there's really no basis for updating the plan. And hence, all of these issues would lead into some of the data that I shared in terms of progress causing projects to be delayed or over budget.
Okay, that then leads us to the next question. So in relationship to progress monitoring, how has digitization specifically transformed that in the construction in the recent years?
So over the past decade, there's been 2 emerging opportunities that significantly impact how we look into this issue of progress monitoring. On one side, the significant increase in visual data. Today, it's very common for us to see people, field engineers, superintendents, architects, owners, or even service providers walk around job sites, use their cell phone devices, use professional photography services, use time-lapse cameras, drones, 360-degree cameras, or even laser scanning to capture and document progress using visual data. I mean, there are a variety of reasons the documentation happens, ranging from as-built documentation to having a record for potential litigation issues to safety. But that wealth of data always captures actual progress on the job site. On the other hand, the other opportunity that has led us into looking into this issue of digitizing progress monitoring is building information modeling. The application of BIM has dramatically increased over the past decade. Many companies are using it dominantly for pre-construction constructability reviews or system clash prevention purposes. What we see as an opportunity is extending these models tied to the project baseline schedule as a basis of what is expected to be performed on the job site. So we increasingly see companies create these so-called 4D BIM models to perform quality control on the schedule, to help owners understand how much progress is expected to happen in different phases of a project. So on one hand, you have images and videos that shows you the reality on the job site. On the other hand, you have the simulated environment using BIM and the schedule that shows you what is expected to be done. Putting these two together gives you an opportunity to compare reality against the plan and make sense of how much progress is being made in a systematic manner.
Okay. And is that in any way now then related to what you talked about, which is computer vision? And specifically, as you mentioned, your background also has touched upon AI. Could you explain for the novice what is computer vision and how that might be applied in the construction sector?
Absolutely. So before I get into the computer vision piece of it, I want to say why images and videos. If you think about progress tracking, you can use all kinds of sensors to automate the process of capture. You can look into RFID tags, you can look into barcodes, you can look into GPS data perhaps. My interest in images and videos were dominantly because construction people are visual people. Seeing is believing. When people see how progress is evolving on the job site, when they see quality issues, when they see coordination issues that can be resolved through RFIs, requests for information, there's really a basis of taking advantage of that type of data. So I wanted to take data that is great and can be used as a basis of providing this feedback loop to the plan. At the same time, I want to make sure that I use the data that shows the context of the work. And hence, I, really fascinated by looking to images and videos. So computer vision is the study of these images and videos. I would like to call it computer vision for construction, which what it really means is the study of images and videos to detect, analyze, and understand construction objects. These could be elements that are being placed on the job site, columns, beams, slab on grade, and so on and so forth, all the way to construction resources, detecting workers, detecting equipment, and being able to understand their activity, understand their relationship to the environment from a safety perspective, from a productivity perspective, and being able to compare them against the model. So we can use them as a basis of progress tracking. So computer vision provides us with the ability to detect objects. It provides us with the ability to generate and understand geometry of the scene in 3 dimensions using overlaps or the motion that we see between images, and helps us having enough geometry and appearance data that can lead us into automating progress tracking.
Okay. And so computer vision is one of those technologies. As an expert within that digitization realm, can you tell us more about any other new emerging technologies that you have witnessed in construction that may affect progress monitoring?
Absolutely. So it's more than a decade that I've been working on this problem of progress tracking. And computer vision is a type of AI, artificial intelligence, but there are other aspects of AI that can also help address this issue. So I would like everyone to imagine a visual project control system that has 3 components. One component being BIM plus a schedule that shows you what is expected to be built on the job site. The other aspect of it, the process of capturing and modeling the reality on the job site, which is analyzing images and videos, transforming them into point clouds and models that show you the reality. And the last aspect being comparing these two so you can always see the actual deviations in terms of how much progress was expected to be achieved versus that reality. But the moment that you compare reality against the plan and putting that over project timeline, you can also tap into predictive data analytics to analyze and forecast risk as it applies to the project schedule. So, for example, can we automatically detect locations that are at risk of potential delays? So when project teams go into weekly coordination meetings, instead of reacting to problems that have happened over the past week, they can proactively look into issues that are upcoming in the next 2-3 weeks, whatever they had when they look at the schedule. So they can proactively tap off that potential delay from happening as opposed to reacting to that. So this predictive data analytics is a really exciting area that can tap into this emergence of data that we have on the job site and help us be more proactive in terms of how we're looking to deploying project control system. From a research perspective, we can go beyond predictive and you can look into this rather buzz term called prescriptive data analytics, which what it means is that now that you have ability to compare them, now that you have ability to forecast the future, can you provide us with recommendations on how we have to revise the schedule? What are the strategies that we need to implement on the job site to make sure we can bring the project back on track to finish on schedule and on budget? So that's also another aspect of AI that's pretty exciting in the context of visual data for project control systems.
That's interesting. Is that something that you would deem similar to an AI assistant?
Yes. In a fashion, it is, again, the angle that we've taken to it is by tapping into using the data that already exists. Images and videos already exist. BIM already exists. Every project has a schedule. So wanted to see how we can, enhance the foundational aspect of AI by creating new algorithms that contribute to the body of knowledge and at the same time really address the problem that we have in industry, which is the desire for having automated techniques that detect actual deviations, can forecast potential problems, and can also offer recommendation on how to revise the schedule.
Okay. And then outside of your current role as an associate professor, you're also a board member of Reconstruct Inc. Could you please share with us just how you managed to juggle these two areas of work with academia and industry?
Absolutely. When you live in the world of construction, interfacing with AI or, digital solutions, there's always the aspect of translation and transition of research into the practice. And I was always fascinated by this because every single problem that we try to solve is really motivated by a practical problem that the industry is facing today. And because we're in academia, we're always interested and focused on offering foundational solutions that contribute to the body of knowledge. So if you work in academic settings, the deliverables are typically prototypes, research prototypes. They can demonstrate that concept. They can validate that method. And you make a publication to disseminate that knowledge with the audience. But that's not good enough for the industry. Industry, especially in 2020, is really looking for solutions that can be validated in real-world settings, solutions that can be scaled and sustained across many projects. So being able to bridge this gap between a research prototype to a prototype that really works for the industry and can scale was something I was really fascinated in. So I decided to get more and more deeply engaged in entrepreneurship activities by first disclosing technology through university, licensing that technology out of the university through a startup company, and having that company really transform that research prototype into a practical prototype and make a real solution out of it. We really started back in early 2016 with Reconstruct, taking some of the earlier ideas that we had on progress monitoring and building a practical solution off of it. We've come a long way since early days that our team was really limited to just a handful of people, to a team that has scaled to 30, 35 people across 4 different offices. And the technology of Reconstruct has been deployed with more than 50 clients over 450 projects around the world, mostly in the US, but we also have seen the application of it in Japan, Australia, and Europe.
That's really inspiring. Thank you. And then for our aspiring researchers within the same field, what advice would you give to them when choosing to try and make an impact or change within our industry?
Yeah, I want to point out to the biggest learning that I've had through this transition back and forth between academia and startup world, the way we perceive value in academia is different from the way value is perceived in real-world settings. Every single publication that happens in construction is motivated by a problem, but the nature of that problem is transformed into academic language and obviously leads to solutions. But because most researchers really don't get the opportunity of deploying their prototypes or solutions at a scale, they're really not exposed to how people perceive that value, whether they would consider paying for it because they actually see that value, and what are the KPIs, key performance indicators, they would use to evaluate that system for the purpose that's being built. My experience of transitioning back and forth between academia and startup has really opened my eyes into how industry perceives problems, how industry perceives research at universities, and the need and the fundamental aspect of entrepreneurship. I really believe today, for those folks who are engaged in construction digitization research, anyone who interfaces some element of data analytics and construction, they really need to be engaged one way or another with startup companies, with advanced technology companies, to be exposed to the real problems and make sure that their solution really addresses that problem through translation of that technology. That doesn't mean that they have to be engaged in the process of entrepreneurship or everyone has to, do a startup company. What it really means is making sure they're engaged so they can be exposed into making sure that they really understand how the pain point is being perceived from an industry and value proposition is being assessed.
Thank you for tuning in to listen to BeyondBIM podcast. If you enjoyed this episode and want to hear more from our latest episodes, then you can visit BeyondBIM, which is available on SoundCloud and iTunes and all the other major podcast providers.